Alright, in this short video, I would like to summarize the results of our class research project, our apparent time study of rhoticity among native-born and raised Bostonians. The data, as you all know, were collected by you in the context of our course. As you all know, the study that I'm describing relates to an investigation of variation in rhoticity, and we collected a lot of data. We collected a little over 1,900 tokens of post-vocalic tautosyllabic R, and our goal was to explore the possibility that native Bostonians, as residents of the larger New England English dialect region, are participating in a sound change whereby rates of rhoticity are increasing in apparent time. So the data were collected by 27 students in the course, and we wound up drawing our data from 10 different individuals who were born and raised in Boston. And the headline here is that the class data very strongly aligns with the work of Jim Stanford. His recent book on New England English, in addition to other studies, finds this trend emerging whereby regional dialects seem to be fading, and the New England English variety seems to be no exception. So let's talk through the variation in the response variable, namely the presence or absence of rhoticity. What you can see here is that among the overall tokens, the majority, about 3/4 of them, there was an actual rhotic consonant observed. So 72.5% of all of the sites of variation were realized as R full. About a third were then realized as R less, or rhotic absent, or vocalized. And then there were a handful of can't tell tokens, and we're going to exclude those going forward. So as we look at the effect of the various social and linguistic factors, just keep in mind that the overall rate of rhoticity is around 3/4 of the time. Okay, so in these plots right here that summarize the effect of the various linguistic factors in the study, the dotted line indicates the overall rate of R fullness, R presence, rhoticity, and the red indicates R lessness or vocalization. What you can see here is that following sound seems to covary with R fullness, such that when R is, which is to say, when a target segment is followed by a vowel, it's more likely to get produced as an R. When it is followed by a consonant, it's a little bit less likely than the overall distribution to get realized. And when it's followed by a pause, it's further reduced in terms of its probability to get realized as an R. The next variable, in terms of stress, it's a little hard to see. The effect is really rather small compared to the effect of following sound. We see that when a target token occurs in a stress-bearing syllable, it's a little bit more likely to get realized as a consonant rather than be vocalized, that it's a little more likely to be present. Then you can see the results for number of syllables are basically non-existent across the variables that we have, that is, across the values for which we have a lot of data, that is, words of 1, 2, 3, and 4 syllables. And there's a little something going on with these longer words, and in fact the multivariate analysis, which you can review the details of in the report associated with this video, there actually seems to be an effect for word length such that very long words are more likely to be R full. I I speculate, I suspect, rather, that this has something to do with the relatively low frequency of very long words, and they are more likely to be hyperarticulated or less exposed to the effect of the reducing effects of frequency. But in either case, at the bivariate level, that is the level we're looking at here, it doesn't seem to be the case that there's too much going on with word length. And then finally, you can see in this box plot that with respect to speech rate, that the higher the log speech rate, and you have to reverse this in your head a little bit, the higher the value is for this variable, the slower someone is talking, because this measures how long it's taking them to produce a syllable. So the slower the speech, the more likely that you're going to get an artful realization. Okay, let's shift our attention to the social factors. What we see across our speakers here is really quite a range. So Mel King and Louise Hicks and JFK, they're all around the 75% R-lessness zone. And then people like Mindy Kaling are interestingly totally invariant with respect to this variable. So there's quite a range of variation across the speakers. When the speakers are collapsed according to generation, those born before and after 1962, there is a whopping difference in their R-fulness. Those born before 1962, in fact, prefer R-lessness, so their rate of R-lessness is more than 50%. That number has massively reduced in those individuals born after 1962. Then with respect to ethnicity, what we see are results that are actually in the aggregate consistent with Lebov's arguments over the years, namely that non-whites do not participate in white working class regional vernacular. Now, when we get into the details of the actual speakers, there are a couple of exceptions. So Mel King is in fact African American and is at odds with this general tendency, but the data do indicate a strong effect of ethnicity such that non-whiteness really being of Latinx or Indian American origin really disfavor R-lessness in our data. And then there seems to be an effect of style of recording where there's variation across different styles. It's kind of hard to reconcile how, say, stand-up comedy relates to a formal style versus a speech, rather. So I wouldn't take too much away from that, but we'll summarize the relative relationship of the linguistic and social factors in a moment, but let me show you the other social factors. Interestingly, in the data, we have only two occupations. We have politicians and performers, and for very interesting, one could imagine, very interesting social reasons, the politicians are much more likely to be R-less, that's in red, than the performers. With respect to education, things are basically flat, though we'll see in the multivariate analysis that there's something going on with education. And again, I think that there's an interaction going on here with occupation, education, and sex. And because we don't have a ton of speakers, it's a little bit difficult to tease these things apart, but hold on just a moment and we'll get to that. Then with respect to current residents in Boston, I've included the NAs here because these are participants who are deceased. That's Hicks and Kennedy. But what you can see is that among the currently living participants in this study, those who are current residents of Boston have a significantly higher rate of R-lessness. So one might speculate that the exit of several of these professional performers to places like New York City, which is now Artful, and Los Angeles, where many of them live, also has affected their linguistic behavior post move, as it were. And then we see a difference between the men and the women in the study, which is largely in line with the with with the analysis that one I think would be tempted to apply to this variable, which is that it's a change from above, and women are in the lead here. Again, things get a little bit fishy in that we don't have a ton of speakers. We have a lot of data. We have 1,900 tokens, but at the speaker level, we don't have a ton of data. So I think we really have to kind of qualify that interpretation. But if the data set were larger and similarly structured, I think that would be the conclusion you could draw. So let's put these things together and then wrap up. So there's a technique referred to that's referred to as conditional inference tree building or binary partitioning algorithms. And basically, what they do is they take all your variables and they try to find the simplest and most internally homogeneous binning of your data according to the predictors. Now, if you want to see all of the statistical details, the various regression analyses associated with all of the predictors, you should check out the report that I wrote to accompany this video. I didn't want to get bogged down into the details because I know you have a lot of presentations to watch, but what this what this image shows is that when we put all of our predictors into the partitioning algorithm, this particular algorithm likes to build a classification system of the data on the basis of just two predictors, namely the generation of the speaker and then following sound. And the way to read this is that the partitioning algorithm says, okay, you've given me all of your social factors and all of your linguistic factors as potential predictors. And here's what I need. I need generation first. I'm going to bin people according to those born before 1962 and then those born after. If we go down this branch here, what we see is that for those born after 1962, almost all of the time, they're actually producing consonants, okay? So around 5 to 7% of the tokens produced by people born after 1962 are R-less, okay? So what the algorithm says is, I don't care about any other factor. I don't care about their sex, their speech rate, the length of the word, the following sound. All I care about is when were they born. That gives me one really internally homogeneous bin. Okay. On the other side, those born before 1962, we get yet another break in terms of following sound. And here what we get is that when the target token is followed by a vowel, we get considerably greater R-fulness, and when it's followed by a pause or a consonant, we get considerably less R-fulness. So what you might say is that in this particular tree, a target segment is increasingly likely to get realized as a consonant if the individual is born after 1962, or if they were born before 1962, if the target segment is followed by a vowel. The environment least likely to promote an R-full production is the speech of someone born before 1962 and the target token is followed by a pause or a consonant. All right, so a different partitioning algorithm gives us a slightly more complex tree, which I want to talk through before we wrap up. What this algorithm does is it says, I'm going to make use of some different variables. And so these algorithms are just a little bit different. And this one is happier to make more branches in the tree that gets built here. The takeaway, though, again, is the same. Generation is what matters the most, okay? And here we've got our afters on the left and our before 1962s on the right. So let's start with the born after. What the tree says is, okay, put the people born after into one bin, and then what I want to know is how fast are they talking? Okay, and if they're talking relatively slow, that is a larger value for this variable means that they're talking slow, then you get not a lot of R-lessness. You get lots of R-fullness, okay, R presence. Okay, if they're talking kind of fast, relatively fast, then I want to know what's their education level. If they have more than a bachelor's degree, they are more likely to produce an R-full realization than those who have just a BA. Now, again, we have a relatively small number of tokens. Excuse me, we have a lot of tokens, but a small number of speakers. So we can't really take this to the bank in terms of generalizing. We can draw the conclusion that this is what's going on in our data, but we can't really generalize to the population that this shift in apparent time is related to education. But so let's now move our attention over here to those born before 1962. And yet again, we get confirmation that among the older generation, following vowel largely for them favors an R-full production, okay? And then if we look at the branch for target tokens followed by pauses or consonants, yet again, we get a division along the lines of education, but this is a little bit, it's a little tricky, again, in that we don't have a ton of speakers. So these individuals really refer to Louise Day Hicks and JFK, who were both attorneys. They both got attorney-level degrees. So we don't want to make too much of this education variable, especially because it's actually at odds with the results for this education variable, where it looks like more education corresponds to greater R fullness, where here more education corresponds to greater R lessness. And what you can see there, of course, is that really generation is doing a ton of work for us, and these education variables are doing less statistical work. But then let's just look at one last division here, because it actually reinforces the effect of speech rate, namely that slower speech, again a higher value here corresponds to slower speech, promotes R fullness relative to faster speech. Okay, so what's neat about these algorithms is they give you a sense of how the variables interact with each other to produce maximally similar groups. So we've got these 7 bins down here, and really what the tree tells you is, if you want to know whether a target token is going to get realized as R-full or not, the most important thing to know is, well, when was the person born? Okay, if it turns out they were born after 1962, then you want to know how fast are they talking, okay, and then how much education do they have. If they were born before 1962, what you want to know is, all right, is the following sound a vowel? Then it's very likely to get realized as an R. If it's not realized as, if it's not immediately before a vowel, and instead is followed by a pause or a consonant, then you want to know what is their education level and how fast are they talking. One more time, I think it's important to qualify the generalizability and, in fact, the coherence of the social effects, in that we don't have a ton of speakers. But here's what we definitely can say. What we have here is a plot of our 10 speakers by their rate of rhoticity and their year of birth. And it doesn't get any clearer than this, folks. As year of birth increases, rate of rhoticity increases. Now, I think a follow-up study, we'd want to definitely get some more individuals born between 1930 and 1960 to see whether the shift was like that, which is to say just at one day everybody turned on the R switch, or whether it was relatively gradual. And of course we'd want to collect a lot more data, but we can, on the basis of these data, draw a number of conclusions pretty confidently. So our results are highly consistent with research showing that post-vocalic R-lessness, perhaps the most stereotypical feature of the New England dialect region, is fading fast. The new norm is R-fulness. Look at this, right? The data suggests that for those born after 1962, post-vocalic R is no longer a site of much variability. For the younger generation, when R-lessness does occur, it may be simply the result of the reducing effect of faster speech. So it's an articulatory phenomenon rather than a site of any kind of stable variation, possibly. So while the number of the speakers in the study is small, the results are strongly suggestive of a sound change very near or at completion. So I think we can say that, like New Yorkers before them, Bostonians are on their way to living in an R-full city. So thank you so much for your work this semester. I have been nothing short of amazed by how well you all have continued to work together under really suboptimal conditions. And I'm extremely grateful that we were able to, both as individual teams, as individual team members, and collectively, generate some very insightful and fun and interesting scholarship. I hope you all feel like you got something out of the course, because I certainly did. Thanks so much.